Hi everyone, welcome to my new video in the Mathematics Essentials series. This video is on radians. Okay, so I will say what radians are and explain them. What are they? Well, basically radians are another way to measure angles, okay, other than degrees. If you are going into something like physics or engineering or more mathematics, you will tend to rely on degrees much less, and you will pretty much end up working almost exclusively with radians when you are talking about the size of an angle. Okay, so let's start off by noting that 180 degrees is equal to pi radians. Okay, if you were to multiply both sides of that equation by 2, you would see that 360 degrees is equal to 2 pi radians, okay? And it's common to have a superscript with a lowercase r to indicate radians, but often some authors write nothing because it's understood from context that we are talking about angles and circles in geometry, perhaps angles and triangles if we are doing trigonometry, and that we are working in radians. This is another notation you might see, okay? A superscript with a C, but that's not very common. Okay, so let's see how radians come about geometrically. Let's have a circle. And I will superimpose this circle onto the Cartesian plane. Okay, so this will be the horizontal x-axis, and this will be the vertical y-axis. Okay, so this is the y-axis. This here is the x-axis. Okay. It's the ink to shape function was still on. Okay, so this here is the y-axis, and this length here, so this would be the origin where the blue dot is, so that would be the coordinate point x equals 0 and y equals 0. Okay, from the origin to this coordinate point here, okay, this here is x equals 1. Okay, this here is going to be y equals 1. This here will be y equals -1, and this here will be, you guessed it, x equals -1. Okay, and that means that this circle has a radius of 1 unit. So that's why we call this the unit circle. Okay, more on the unit circle later, in a later video. But since each point on the circle is equidistant from its center, and in this case its center is the origin, okay, then from the center to any point on the circumference of the circle, the distance is also 1 unit. So let's say we just take this point here, okay, and we draw a line from the origin to that point. Okay, so here's our line, I'm drawing it in green. Okay, it turns out that the length of that green line is also going to be 1. I'm going to shade in the positive part of the x-axis between the origin and x equals 1 in red, and you'll see why I'm doing that in a second. Okay, so the length of that red line is also 1. The length of the red and the green line is 1. Now, I want you to consider, I'm just going to draw a red dot here. I want you to consider the arc length of this circle here between the red and the green points on the circumference of the circle. Okay, so I'm just going to shade that part of the circumference in blue. So I want you to consider this arc length of the circle here shaded in blue. And imagine that we straightened out that arc length. So we took it over here to the right and we straightened it out so that it no longer had any curvature in it. Right? Well, if it turned out that the length of this straight blue line was 1 unit, then the angle required, so this angle here, required to produce that much of the blue arc length, namely 1 unit's worth. Let's just call that angle theta. Okay, it turns out that theta would equal 1 radian. So can you see how there's this correspondence between the size of the angle theta measured in radians and the arc length of circle that it produces? So if the angle is 1 radian, it will produce 1 unit's worth of length of arc length of the circumference of the circle. That part of the circle that's shaded in blue. Okay? So just to reiterate this with quantities other than 1, so let's say I have a circle and just draw a Cartesian plane quickly. Okay, this won't be exact, but good enough to understand what's going on. So this is the y-axis, this is the x-axis. Let's imagine that our angle was this big. Okay? So that the amount of arc length we traversed was from here, where x equaled 1 and y equaled 0, all the way around, so basically a semicircle's worth of arc length to here. Okay? Well, this angle here, let's call it theta again. Okay? Theta, well, just think in degrees for a moment. How many degrees would the size of theta be? It would be 180 degrees. Okay, but note that at the start, we said that 180 degrees was equal to pi radians. So, turns out that theta is equal to pi radians. Okay? And since there is always this identity between the size of an angle measured in radians with the arc length of the circle traversed, what do you know about the length, the arc length of what's shaded in blue on this unit circle? You know that the length of what's shaded in blue is also pi units. Okay, so that's how radians work. Okay, a radian is a measurement of angles, and they're defined in such a way that 1 radian produces an arc length of 1 on a unit circle. Okay? Now, why do we prefer to use radians rather than degrees? Well, for various reasons, radians are more accurate than degrees, because often with degrees, you're going to have to round up or down. It's often difficult to keep things in the exact to write things according to their exact value. But when we work with radians, we can keep things, the size of angles and trigonometric calculations in their exact form by taking advantage of mathematical objects like surds, for instance. And that helps us to just work through a problem, making sure that all of the quantities we are referring to are written precisely. There's no rounding up or down, there's no approximation or anything like that. Okay? So radians allows you to keep things exact when you're solving a problem. And therefore they allow for more accuracy. So one last thing before I wrap up this video. Let's imagine, actually I'll just draw a Cartesian plane again. Oops, I'll stick to gray. So here's my Cartesian plane. Okay, horizontal axis is the x-axis. Vertical axis is the y-axis. Now, the convention in whenever we're working with angles is that angles are measured anti-clockwise from the positive x-axis. So the positive x-axis, if this is where x equals 0, okay, then all of these values to the right of x equals 0 is what we mean by the positive x-axis. So angles will be measured anti-clockwise in this direction from the positive x-axis. Whatever the angle happens to be, okay, it's measured anti-clockwise. So this here would be, if this was our angle theta, theta would equal pi radians. But that doesn't mean there is not an interpretation for the meaning of negative angles, okay? So just like with numbers, I'll just draw a real number line down here. Okay, so imagine this is a real number line, okay? And here is 0, right? Well, we interpret the positive numbers as the numbers that you would encounter when you head in this direction from 0, okay? And if you wanted to encounter negative numbers, all you have to do is head in the opposite direction from 0. You just head towards the left of 0, okay? Well, a similar kind of thing occurs when we talk about negative angles, okay? So angles are typically measured anti-clockwise from the positive x-axis, but if you get a negative angle, that just means the angle is being measured anti-clockwise from the positive x-axis, okay? So if we have an angle here, I'll call it phi. Well, you can see that the size of that angle in degrees is 90 degrees, okay? But when we are talking in terms of coordinates on a Cartesian plane, we don't really say that this 90 degrees and that this 90 degrees, this angle which has the same size, which is 90 degrees, we don't say that they're both 90 degrees, okay? Since theta is measured anti-clockwise from the positive x-axis, we would say that theta equals 90 degrees, or in radians, pi over 2 radians, okay? And phi, okay, its size is 90 degrees, but since it's measured clockwise from the positive x-axis, we say that phi equals negative 90 degrees, or negative pi over 2 radians. Okay? So that's how you interpret negative angles. Notice that to get to this point here, okay, we could have taken an anti-clockwise path. All right, so here's another Cartesian plane. Okay, we could have got to the same point here by taking an angle like this. Okay, and that angle would be 3 pi over 2 radians. Okay, so that's just about everything I wanted to cover on radians. Okay, so just to recap, 180 degrees is equal to pi radians. Okay, 360 degrees is equal to 2 pi radians. All right, this is handy to remember as well, even though it just, it follows from pi being, pi radians being equal to 180 degrees, but 90 degrees is equal to pi over 2 radians, and 270 degrees is equal to 3 pi over 2 radians. Actually, I'll throw in another one. 45 degrees is equal to pi over 4 radians. And you can see that all of these facts would just follow from this fact, that 180 degrees is equal to pi radians. Just work on both sides of the equation, dividing or multiplying by whatever you need to produce the amount of degrees you're interested in converting to radians. And you could produce this fact, or you could produce this fact, you could produce this fact, and you could produce that fact as well. Okay, now radians are defined in this geometric way here, where the size of the angle measured in radians corresponds to the arc length on a unit circle produced by that angle. So 1 radian would produce an arc length of 1 on the unit circle. Okay, unit circle having a radius of 1. Now, the other thing I mentioned was that angles are typically measured, so this is just a convention, okay, they are measured anti-clockwise from the positive x-axis, but that doesn't mean that negative values for angles are meaningless. Okay, just like when we typically count, when we count objects, we count in positive numbers. Okay, you wouldn't count rocks in negative numbers, but that doesn't mean negative numbers have no meaning. Similarly, negative angles are not meaningless either. Okay, negative angles just mean that the angle has been measured clockwise from the positive x-axis. Okay, so that pretty much wraps up everything I wanted to cover on radians. If anything in this video wasn't clear, just please post a question in the comments. I typically respond within 48 hours. If you found this video helpful, please give it a like, feel free to share it with your friends, and if you want a notification when I release another video, subscribe to my channel. Until next time, bye for now.